One more time. Hello, greetings, everyone. Welcome to our online webinar today. My name is Candan. I'm your presenter today, together with my colleague Serhan. He is our R&D chief engineer. We will be presenting you this webinar. It is about Stewart Platform, its fundamentals and applications. Please be aware that this is a live webinar and it is also being recorded. So for those who will be missing it, you can watch it later on as well. But during our webinar, if you have any questions or anything you would like to share with us, please write it to the chat box of the YouTube stream. So at the end of the webinar, we will be checking these questions and we will do our best to answer them in the end. So let's get started. We will have a short presentation today. So agenda of the webinar is that we will have a presentation, and side by side during the presentation, we will be doing some small demonstrations using our Stewart platform that you can see next to Serhan, also next to me. Okay. So let's start with the presentation. Okay. So there's a small technical wait time. We are waiting for it. Apologies for that. Okay. Meanwhile, let me also shortly introduce you our company. So we are streaming today from Acron Robotics, and our company is manufacturing these Stewart platforms. And we are offering these products worldwide. So okay, let's go with the presentation now. Okay, first of all, what is the Stewart platform for those who maybe not heard it before or willing to learn more about it? So a Stewart platform is a parallel manipulator robot, which is widely used for R&D purposes, or also it is also used in industrial applications as well. This part is it is about our company. So I should have started this one. Acron, our name stands for these three words: accessible robotics and mechatronics. And we are our headquarters are in Istanbul, and countries as well, distributors network also. And we have been working in this domain for some more than 10 years of time, and we have many customers using our products in their research or industrial applications. So again, back to the Stewart platform, also known as a hexapod positioner. So a Stewart platform consists of 5 major parts, as you can see here next to us as well, and also Serhan. So the first 2 parts they are sort of very similar, identical to each other, the plates. So that you can see from here as well. We have 2 plates. One is generally the one that is moving, that's the top plate. And the second plate is the base plate, where all things are, like all the legs are also mounted. There are some special cases where the top or upper part of the plate can be also stationary, and the lower part can also move. So actually, it really depends on where you fix your plate. If you fix your bottom plate, then it becomes stationary, which is generally the use case. But if you fix the top plate, for example, to a robotic arms and effector, then the opposite part of the platform starts moving. Next, we have the actuators. So each Stewart platform most generally, has 6 linear actuators, and these actuators are the key to the positioning. So they expand the track and based on their movement, the moving plate, the top plate, it moves in space. Three, four, six different directions. We then have the joint parts. These are the parts where the actuators are connected to the plates. So red dots there. And so we have lots of these joints, and each joint uh, is normally identical, but between different products from different manufacturers, the there are different types of joints. So, for example, we generally use cardan joints, and but there are other different magnetic joints and similar in the that are used in different applications. Finally, last but not least, and maybe the most important thing, is the control unit. Here in that picture, you cannot see it, but from my opposite side, you can see it. That is a cabinet, kind of a control unit. We have a microcontroller, and for small devices like the one that Sarhan is showing, the controllers are generally very small as well because the power consumption is low, so that there isn't a tough requirement for cooling. And some manufacturers also integrate it to their bottom or base plates. But if there are heavy loads, like more kilograms, then there needs to be like a cooling and similar like space required controller, and that would require an external electrical cabinet like control. And what controller is used for? So it is like controlling the actuators to move linearly, to measure their position, to measure the top plate's position, its orientation, and all the related algorithms to position, to move the Stewart platform. So the controller is the brain of the product, in other words. So let me go to the next slide. So we know the basics of it, but now we would like to show you so what can it do? What kind of movements it can generate? This is where the 6 degrees of freedom comes into the play. So in general, Stewart platforms have 6 degrees of freedom, but there are some special cases where additional axis or freedom can be implemented on top of the plate or to the bottom of the plate. But in most of the circumstances and for the demos of today, we have these 6 main motions or movements. So from the top, I will introduce a little bit, and then meanwhile, I'll ask Sarhan to do kind of a small demonstration. So it might be good to like change the screen to the wider version. Please, we will be working on that part. And let me also explain first the surge motion, which is the x-axis motion. We call it the x-axis, which is like this perpendicular axis currently moving. This is the surge movement or x-axis movement. Second movement is orthogonal to the x-axis, which is y-axis. It is also called like as sway in naval words. So sway, if you notice, it is like lateral motion towards the field of direction. And the third dimension is the height, or in other words, they call it the surge, heel motion, so up and down, in other words, and it goes up and down to execute that motion. These are the linear type of motions, and we also have the angular motions or angular workspace. When the platform moves around the axis, it is also called roll motion. And this one is the roll motion. If you remember, we were having like X in this kind of motion. And when the platform moves around the y-axis, it is called roll motion. Sorry, pitch motion. So this one is the pitch motion, what we see here. And finally, when it is rotating around the z-axis, the height axis, it is called the yaw motion. So it is rotation around the z-axis. So these are the 6 degrees of freedom that Stewart Platform can achieve, and generally that is what it is required to move the any workpiece or any device under test in the free space. So okay, let's move back to the presentation. And we will be coming back to the user interface, how we are achieving these motions, but this is the primary information about the Stewart platform. Now, before moving forward, so we are doing some demonstrations, I would like to inform you that we have 2 different Stewart platform types, and we call them standard unit, which is the one we are doing demonstrations today. Generally, it is less, it's quieter and having less dynamic, like vibration kind of motions, which is quite better for webinar kind of a event. The standard platform is widely used for educational purposes and small prototyping activities. It has a fairly low payload capacity, and also the components are they are meant for standard laboratory usage, not for outside or not for extreme harsh conditions. The Pro platform, that is the reason we name it Pro or professional, is that it is more like tailored towards industrial purposes or heavy duty or 24/7 continuous operation applications. In such applications, generally higher payloads and or speeds are required. Both platforms share similar DNA, or their contents are very look alike. And for the DNA, we are trying to share the same software experience, the same closed position control methodologies. Main difference is generally the payload speeds and also the environmental durability, or like outside conditions durability, if I can say so. So now next, where the platforms are the Stewart platforms are mostly used, and we have seen a lot of different applications, but mainly these applications are focusing around these 4 pillars or 4 domains. The first one is, it is a very wide domain, but they are generally focusing on a couple of major applications. So the aerospace and defense applications, and there we see a lot of flight simulators, drone sensor, drone testing, drone related manufacturing related activities, and antenna testing or antenna modeling kind of applications. So these are very common, fairly common in A&D sector or application space. Second, there are medical technology, medical applications. We see 2 different approach here. The first one is kind of human and machine interface or interaction, and it is generally used in kind of orthopedic applications or sometimes surgery or surgeon assistive devices. So these are mostly like human and interaction, human and machine interaction. And there are also kind of simulator and rehabilitation applications where the patient and the machine is getting into contact and like interacting to each other. This is these are the applications we see in medical technology or medical space. Now, for the manufacturing, there are many different possibilities and applications. In some cases, Stewart platforms are used as an extension to a robotic arm. In other cases, they are used for alignment applications, like in photonics, optics, manufacturing. So anything that can need a 6 degree of freedom location positioning at the manufacturing floor might be like a target application for a Stewart platform. And finally, for the advanced research, we do have hydrodynamic or aeroelastic simulations, especially for wind-related or sharing some demonstrations, like some example applications for that as well. So let me go into our first use case. So this one is actually, it is from an aerospace company called Photokite, and they let us share their information, and detailed information about this application is published on our website as a case study. So Photokite is a drone manufacturer, and in reality, it is both an aerospace application, but also a manufacturing test application. And the Photokite, so they are manufacturing their drones, and these drones are they are used in the civil authorities for emergency operations, like firefighters or earthquake research applications. So Sigma drone is the brand name of the Photokite's drones, and they are a special kind of a drone which is tethered, and it is operating 7/24 in an emergency area, sometimes just for recording a video of the area, or sometimes to measure some like low-level noise, vibrations, so on and so forth. It would require a perfect IMU and also a force sensor to identify the length of the amount of force the drone is carrying, or the amount of the weight. So these two parts of the IMU and the force sensor, they are integrated into their drone. In many drone, by the way, applications, there is at least one IMU sensor. But for Photokite, they need to have a perfect calibration, and it should work like in harsh conditions as well. So to calibrate these sensors, every Sigma drone that is manufactured on their manufacturing line goes on top of one of our Stewart platforms. And Stewart platform is doing what it requires, so it gives some pitch angles or some angular motion, and like also forces as well to the drone sensor. And then they start recording the data of what is the applied angle from the Stewart platform or the applied force, what the sensor on the drone measures. And in the end, they output a custom calibration file or lookup table, in other words, and eventually they embed this file to their drones, like own software or firmware, in other words. And that is like a long operation, because they need to repeat this for every half degrees or 0.2 degrees, 0.1 degrees in some cases as well, and through all the operational workspace. And thus it requires automation as well, which also needs to run in parallel, because the operation takes more than 5 minutes or 10 minutes. and they have multiple Stewart platforms. And for the test operator, what he does, he places the drone on the plate and they fix it for some how, and then they just go to their computer, select the corresponding Stewart platform, and hit run button. And when they hit run button, there is a pre-recorded file. It is called CSV file. That file starts moving. And I think Serhan also prepared a similar demo with us, not exactly the same file because it, as I mentioned, it takes approximately 10 minutes of time. But the idea is to have a random or a point cloud of data that is like fed from the computer and running on the Stewart platform. So this is our user interface, and we will be like explaining it a little further. But now he is like selecting the file that will be loaded, which is now, as you can see over there. And when we start, these are the motions that are executed.
These are the volumes.
Yes, okay.
Yes.
So maybe let's give one more run, Serhan. So just to like this, because it's now much easier to read from screen. So with every start run, the platform executes the motion and then it finishes its motion. This is a relatively short motion, so it takes a couple of seconds until it completes. And when the motion completes, the platform says that all the motion has been executed. Okay, so let's proceed with our like other use cases, and we will be showing you the how it looks coming on. So yeah, I'm just waiting for the slides to come back. Apologies for a small delay. Okay. So our next application or use case, in other words, is from an advanced research application. So it is kind of a hardware in the loop simulation, and for kind of like structural dynamics testing, by the way. So we have seen this a lot with the wind tunnel. And there are some places, universities especially, aerospace engineering departments, having different size of tunnels, wind tunnels. So from the wind tunnel, they are simulating the atmospheric effects. And obviously, there is always a device under test. And in these kind of applications, it can be a wind turbine, it can be a part of the plane, aerospace part. But generally, that's a model or a scaled version of a final device. And this scale is important because when you scale something down, you need to scale the speeds and accelerations up. Like it is like it works in opposite ways. So there is a device under test that is this scale, the model, and the Stewart platform is there. Generally, it is like under the like wind level or kind of like it really depends on the application. But the model is placed on top of the Stewart platform. Stewart platform is underneath of it, and it is like mimicking or simulating the motions of either the ocean or sometimes it is like the moving vehicle, like so on. And then what they also do, they get some measurements from the device under test. Okay, so the one thing here is the scaling is a challenge, and when you want to have a similarity between the real thing and the observation or measurements, you need to scale the difference. So this is, I think this one is a very different application, although the medium is the same. Okay, again, that will be like sea waves or oceans. But this is kind of a innovative area or a recent application space. So extended reality integration with the motion. So it was very popular about the metaverse and kind of these applications, the XR integration. So in one medical application, the University of Iashi has like created a kind of a mechatronic integrated experience for like medical rehabilitation. And the idea is to rehabilitate the seasickness of the people who are moving on the rafts or small ships or something like that, or even the car sickness can be also a similar application area. So what they did, they placed a small active suspension type of a chair or device of theirs, and placed first a dummy model and then a human model as well, and used the Stewart Platform again to mimic or translate the raft's motions or its coordinates. And at the same time, they were also presenting the raft's video on the VR headset. And the important thing here is to combine the physical reality, the motion of the Stewart Platform, with the visual reality and also the audio reality as well. And they did something here, especially using something called Perlin noise function to get rid of the small latency issues between the video and reality. This is a very strange, interesting application. It is also published on our website as a case study, as well as like published on some academic journals. So I'll wrap up here about the different use cases and applications. And we see generally these three different personas that are using our hardware. So the first persona is from the university, from students or the educators, not the researchers, because research level applications differ a lot. So the student and educator they just want to learn how the robotic system, especially the parallel kinematic system like Stewart Platform works. And they really require a simple to use hardware just to demonstrate or at least try something with it. But the next step, student and educator may work on the same product platform to do kind of a research. The research may be related to the application itself, like the previous medical rehabilitation application, or it can be related with the Stewart Platform's own control system. So we have seen some customers who test their own custom control algorithms, and this is one of our products like special point, because we provide some open source examples for the low level control of the product. And there are API integrations for mostly used engineering software. And on top of that, we also provide some simulation environments for the user to simulate before executing their algorithms. The third persona is probably the persona that we deal or discuss, talk the most. This is the engineers at the industry or who are trying to use the hardware for doing something. So from photokite's case study, we have seen most of the time the Stewart platforms are used for testing the or automating the kind of the manufacturing steps or tests or like calibration operations. And also in majority, the engineers would like to play back some pre-recorded data that they have gathered from somewhere and they just want to mimic, which is the ocean wave example that we discussed. They have some special requirements like they want to have some private network, they want to have like more dynamic motion, or in some cases they need special sensors mounted on top of the platform. And all these cornered cases are somehow open for discussion, and we have seen that we work on that fashion. So these three personas are the ones that we like see a lot. But if you have some other kind of, or if you are representing another industry or another like user persona, please let us know so we will discuss it. Now, the brains behind the platform, as we discussed, is the kind of a user experience or how to use the platform, in other words. So we have already seen the user interface, which is the ready-to-use software for all different personas. And it generally gives the user like almost all the features of the platform. But there is the middle persona, which is the researcher, the person who would like to do something different from what is existing. And for those kind of customers, we provide an SDK and or, depending on the requirement, an API for doing their own either custom motion or custom control algorithms. So there are different programming environment supports, language supports, and example codes as well. And for that one, I think now I will ask Sarhan again to run some, to show us the both of these, like the user interface first, and then the API or coding options. I
Yes.
think we will start
Do you
using.
hear me?
Yes, your sound is.
Stewart Platform comes with the ready-to-use GUI that allows the users to control the device, monitor its status, and create motion scenarios without any programming knowledge. In parameter section, we have calibration button in here. Calibration button used for the converse analog values of this potentiometer, converts the millimeters, and setting their upper and lower values and save them. Also, there are others information button in here, reading the calibration values in here. Also, reading the IMU sensor values, the platform status, and actuators, etc. In manual control tab, control the system in set point and trajectory. The trajectory runs like a specified times to targeted position, like this. I give the 5 seconds to goes up.
So it is more like a set point command, but with a time target.
Yes.
And when you do it without the time target, which is like instantaneous set point kind of a motion. That is the difference.
like that. In scenario tab, allows the users command to create continuous motion scenarios. Is enabled the system move center of the Z, delay 5 seconds, and go lower in 5 seconds, and delay 5 seconds, and power off. Goes to center, waiting 5 seconds, and goes to lower in here, and actuator disabled. In oscillation tab, we gives raw pitch yaw oscillation or XYZ oscillation. It gives the amplitude in the range and also specify the frequency. And initial angle. I give the 90-degree offset, and sorry, I follow the back center first and set again. It's moving the oscillation like this.
Maybe it is good time to explain what the graph section is used for, Serhan, and its components.
In graph section, we can monitor the system status and for kinematic outputs, IMU sensor values, also error status, etc.
Yes, perfect.
You can clear the chat. In a pivot point function, you can change the rotational point. I give the change the Z value is moving that point like this.
Mm-hmm.
I give
It can be explained as the focal point as well. So the focal point of the motion, instead of being the top center of the platform, now it is a virtual point in space above the Stewart platform, and all the motions are translated automatically around that pivot point or virtual pivot point.
it's mostly using on antenna control application.
Yeah, that's okay. I think for this part we are good to go. Can you also show us like an API example where we can like see how it is working, and probably this part is also interesting for the API example.
We are also using the API. I show. Open.
I think so. While Serhan is preparing it, so maybe let's go to the final slides if possible. So meanwhile, Serhan will be presenting the API example. So as we discussed, we have the user interface ready to use, which is like it is shipped with our products by default. Probably many manufacturer does the same. And also there is the API or SDK for custom applications. If there is any feature that is not available or you want to customize, you can use SDK or API to do so. And okay, we have discussed about demonstration part. So we should have mentioned about there are three key parts of the performance. One of them was the virtual pivot point performance, and second thing is that the set point versus what happened. I mean the trajectory following capability of the platform, and then we also have the command and response capability that is important to understand what is going on, what the platform is executing at that specific point of time. And there is the third topic that needs to be, or metric we can say, the response latency. So especially this is important when you are using the SDK or API to do your own application. You would like to know when your command will be executed and when to go to the next command. And that latency is visible and observable, and also it is limited or guaranteed with some time. Okay, Sarhan, shall we check the API example, or shall I go through the slides?
Yeah, we can go to the API.
Okay, so I think you need to.
In here, we are also in same API commands enable to or move platform like this. This message scenarios is important rated before in programming is something by send this first and go to the center, wait 2 seconds.
So actually, this is the same script that we saw on the user interface, but now if we will check it back, so we just combined it into a Python script and building a message list, and then I think when we execute it, it just executes similarly. So that is the part that I wanted to tell. So the every command gets a feedback from the platform, and the latency of these commands and feedbacks, these are defined within some limited period of time, and obviously there is a small Python related software code issue, but the platform moved itself and executed the motions. Yep.
Yes.
Okay then. So let's proceed with the with slides and try to wrap up what we have discussed so far. There are some popular or upcoming features or something that we are also researching. And obviously, everyone is trying to do something with AI and AI robotics applications. And we have seen some academic papers or publications using Stewart Platform and moving beyond classical position control. These are kind of research personnel applications. We are also trying to give access to the Stewart platform itself through a service called remote access, remote laboratory. Especially it is useful if you are working from home and your laboratory, you need to connect to the platform and execute some motions. This can be an interesting option. And finally, there are always requirements for bigger or faster products, and everyone is like trying to scale up their own hardware. So we do as well, and this is the kind of like horizon we are like moving or we are aiming for. Okay, so I think this is like we have made it quite some time, and this is the end of our presentation section. I think there has been some questions during the event, so let's try to like comment or answer them, and we would like to also get 5 more minutes for further questions if you would like. So I will start with the Ercan's message. So I have seen that message while we were discussing that part as well. So in manufacturing, there are many potential applications. We have mentioned about the one for calibration of the drone sensors. We also saw applications for precision coupling kind of applications. So especially when it requires kind of fine and very precise final motion, the Stewart platforms may be an alternative approach to robotic arms. And there are some applications we have seen. And there is a third application. This is very interesting, and has been applied. Stewart platforms can be used for load carry supports as well. So one major advantage of the Stewart platform is that it can carry much higher payload compared to a robotic arm, and it is very useful to move some part of the device or like a heavy load from one level to another. So these are the applications that come out of my mind just like quickly. But if we will find anything else, we will let you know, and probably you will see some videos about that. So the next question, I think, is from Juan Ferreira. And so he is asking for something for Serhan. I'm not sure if he saw it trying to do so, but oscillation command in Python. So the only thing I know is about parsing error. It can be related to the it can be related to the syntax or also the local settings of the computer. This parsing error is something we have heard a couple of times, but it is quite easy to solve. Now, Serhan is showing us the document of the API, which is what we use for the in Python as well. And first thing that we need to be sure about is the correct syntax. So this is how it has to be entered. And second topic that can be related is like the precision of maybe the angle commands when you enter more precise commands, or the workspace as well. But each one gives a different error code as well. So I'm also suspicious about the like local settings of the computer, because sometimes comma and dot differs from computer, from country or region to region. Please share with us some a message after the event, so our technical team, Serhan and I, will also try to help you to solve that problem. Okay. If there isn't any further question, I think we can wrap up today's webinar. Thank you all for attending our webinar. Feel free to share your further questions, comments on the YouTube's recorded video as well. We will try to reply our comments as quickly as possible. Thank you, and hope to see you in our next webinar. See you.